Coming to the big data side, so at present, okay. Uh, at present, you can see this page, right? So, at present, according to Fortune Business Insights, there is a projection that market size for big data presently it have around $345 billion in 2003, and the projection by 2023 it will become $842 billion. So this is the big data technology market size. So it is almost what it is going to increase by 150% with present market size. And along with that, in according to the master.com, maximum big data analytics is the most likely to be top in demand skill for next few years. And among almost 90% of companies are planning to hire new staff with related skills to fill big data analytics. So at present, you can see there is so many job opportunities related to big data, and in future forecast also you can see these forecast you can see the market size is almost going to the more than double in next couple of years. And and skill wise also there is huge chances that getting placements related to the big data. And coming to the big data, so generally big data is helpful to manage, process, and streamline huge data sets in real time. And along with that, if you see this screenshot, so in present market, if you go by industry wise, so you can see in big data side what is the maximum area wise in industry wise. You can see 30 around 30% we have in banking and finance services and retail, manufacturing, IT and telecom, government side, healthcare side, and others. And maximum at present, you can see maximum big data projects are in banking and finance services, retail, healthcare, IT, and telecom. So future we may in other different industry also this scope will increase. So at present by 2022, this is the different market shares related to big data projects. And these projections at present it is, but in future it will increase because based on the data uh, size it is growing, right? So these industry market shares also will keep on increasing. And one more projection, like in North American, if you take North America big data technology market share, so at present we are getting around at present they in 2022 there is one one or three USD billion projection is there, and this value is keep on growing for next by 2020 2030. So next couple of years, at least 7 to 8 years, you can see the projections and how many job openings also. So you will get so many different types of openings related to big data side. And coming to the big data, so what is big data? And big data is like large volume of semi-structured, semi-structured, and unstructured data from various sources. So collection of these sources, we'll call it as big data, basically. And big data, like in software side, if you take big data, so we'll call it as various software tools to manage and collect, analyze, organize, deliver, and access these type of data, different formats of data, we'll call it as big data. So if you take any big data project, so in that project there will be different type of the software tools they have. And those tools mainly we are going to use, we need to collect different data from different type of sources. And after collecting that data, and we need to manage that data, and we they are going to analyze that data, and based on that analyze they are giving forecast, and they're using those data for future business purpose. So this is the main purpose of big data. And you can see a few business benefits also. So here, based on these data, there will be uh, customer insights. So based on the data whatever they are getting, they will check those data. Based on that, customers will get insights from that data, and based on that they will take business decisions. And based on these operations also will get improved, and based on more insights, market intelligence. Like for example, if you take any retail domain, based on whatever the data we are gathering, on top of that we'll do some analytics. Based on that, if you take for example retail domain, if you go to any Flipkart, Amazon, or any site there, if you are trying to buy any product, there you will get few suggestions. So those suggestions also will be depend on our big data side only. So what are the data we are gathering, on top of that data science team they will do analytics and they will give suggestions. For example, if you are buying any uh, shirt for example, and related items, it will give in suggestions. So for those type of suggestions and insight, they need to gather huge data, and they need to analyze that data, and then only they will provide. That is one type of analysis. And few are like, and whenever you are going to do any, if you open any site, Flipkart, Amazon, and based on the season also, what type of products are buying, people will prefer to change from season to season. So those type of analytic also people will do when they will gather huge data, that will be benefit for them. For that also we need to gather huge data. So these type of analysis they can do using only big data. Okay, and this is basic overview. Like once we have data, on top of that data there is a four different categories it will come. One is like storage. Whatever data we are getting, we need to store. For that we have couple of services like Hadoop, MongoDB, Cassandra, like different type of services will be there. Based on project they will use different services. This is for storage purpose. And for analytic purpose, again different services will be there, like Spark or Kafka. So using these services, whatever the data we are getting, we'll process that data and we'll store the data. We'll store into the storage layer. And mining purpose, we have different services like Presto, Elasticsearch. So using these services, if they want to extract any data if you take for example Elasticsearch, so if you want to search anything on top of your data, it will be very fast. Like that, if you want to do any searching purpose, if you want to do if you want to check any data, these services you can use. And finally visualization. So on top of our big data, so Tableau, like Power BI, different visualization tools are there. You can use them, and they can create graphs, like bar diagram, pie chart, like the different charts they can create, and they are visualizing the data. And for example, what are the main challenges in present existing technology? If you take any existing technology, like you might be heard about Oracle database or ABAP, MySQL. These are traditional databases. So these are available from around 15 to 20 years minimum. So what is the problem with existing traditional databases, and why we got this big data technology? Because in traditional databases, uh, generally it will use for transactional basis. For example, if you do any banking, if you take a banking transaction, so whenever there is any transaction is happening, immediately they need to store and they need to update those type of transaction. It will be useful for traditional databases. If you take overall how many accounts are there, there won't be it won't increase drastically, or it won't day by day. But if you take YouTube, Twitter, uh, like these sites, Facebook, WhatsApp, so day by day, the amount it is generating, it is increasing drastically. For example, if you take around 2020, so if 2020, if data is generating, for example, we'll assume around 1 GB, by 2022, say on each date it may be generating around 50 GB or 60 GB, because day by day the people number of people engaging and amount of data it is generating is increasing drastically. So due to that, these existing databases, traditional databases, are unable to handle. And today, because they need to increase vertically and horizontally, so that is not possible in traditional databases. Why? And they face these four issues. One is scale of data, that is volume. Daily keep on we are getting different type of data, and they need to increase with that. Today 1 GB is getting, tomorrow it may become 10 GB. In same fashion, we need to increase our cluster size also, and it should be support that. This is one issue. So if you take Oracle, so it won't handle this much of size. In Oracle databases, there you will get issues. System will get hang, those type of issues you will get. And if you take any traditional databases, whatever data you are seeing there, it will be in tabular format. So it will have columns and it will have rows. So what, it is in proper structured format. But if you try to take any semi-structured or unstructured data, for example, if you want to read one PDF file and if you want to store that data into any database, so traditional approach you cannot do that. Further, there is certain limitation for that. Only structured data you can store it. And if you get with different varieties of data like structured, semi-structured, unstructured data, so for these traditional databases, it won't handle. So this is another case. And velocity of data. So how frequently you are getting the data, and in which in which in that fashion only we need to update also. So this is also one condition. So today we may get 1 GB data, and for every 1 minute. Tomorrow we may get 5 GB of data for every minute. So we need to handle. That is another case. And coming to the veracity, we may get different data from different sources. One source will be in proper format, and from another source there will be so much unnecessary data will be there. If you store same data without doing any cleansing anything, so on top of that, if you are trying to do any analytics, so it whatever the reports it is generating, it won't be 100% accurate. And due to that, business decisions will also affect. So due to that, whatever data we are getting, it should be in proper form. We need to do proper cleansing. We need to do uh, clean the data. So it will come under veracity. These are four challenges with existing traditional databases we are getting. So to in big data will come all these four traditional issues we are getting. So coming to the big data side, big data in big data we'll get data from different sources, and we need to gather all data from different sources, and we need to store into one cluster. So there you can see different type of data. So for example, if you take one is like Oracle database. So from there, whatever the user reports are generating, it will come into the one database. And any transactionals are happening, it may store into different another database. So somewhere you are getting some PDFs, you need to process them. Like that, there will be so many different uh, clusters will be there. From those clusters we need to take data, and we need to cleanse that data, and we need to store in proper format. So the data should be in uh, what expected format, and there should not be any unnecessary data should not be there. So this is our main requirement in big data projects. So overall projects is like we need to gather from different sources, we need to do cleansing, and we need to check any logics, business logics we need to apply. Then we need to store in our big data storage. And coming to the departments, like previously I mentioned, if you come to this slide, so big data projects are there in different, for example, retail. If you take in retail domain, daily how many products are selling, different type of products are selling, those details we used to we will get. So on top of that, we'll get from different sources, and we need to store in proper format. Then there will be data science or big data team itself, they will run some queries, and they are generating some reports. Using some reports, and it we are giving suggestions, what type of suggestions it will be benefit for the business. So those type of suggestions will happen in retail side. Similarly, telecom, healthcare. So every industry have different scenarios. Based on those industry scenarios, big data projects will be changed little bit from one project to another project. And tools also, different tools we may need to use, and based on the project it will change. And based on the requirement, we may need to store data into, based on industry and company. Project will be there in on-premise, cloud, it will be differ. So based on that, tools also will change. So this is overall big data side. And coming to the curriculum, so we'll cover all these topics. One is like, we like big data projects, mainly we are using two programming language. One is Python and another is Scala. Maximum projects are preferring Python. So if you want Scala, we'll cover Scala also. This is first. We'll go to the basics of Python. What are the required details for Python? We'll explain them. And for big data, we need SQL also. So we'll explain basics of SQLs and different queries. What are the queries we are going to use, right? Those queries also will explain. And on-premise, we what are the on-premise big data platform? It will be on Unix platform. So we need to learn Unix also. So these three basics we need to know. And after that, we'll go through the Hadoop part, introduction to Hadoop. In Hadoop, we'll explain architecture and cluster, all those details. Then in Hadoop, there will be HDFS, this is storage layer. Then we'll explain about Scoop. So here we'll explain how to import data from different RDBMS system to Hadoop. And this is for query language. It little bit similar to the SQL, but it will have its own processing engine, and it will execute big queries on huge data also. Then we'll come to the Spark. This is the main part. So whatever the big data projects, every project, 90% projects will use Spark only. So based on the Spark, along with few other tools, there we'll have in every project. So in Spark, we'll go deeply into the Spark, and in Spark we can use four languages: Java, Scala, Python, or language. In present market, maximum projects are there in Scala or Python. So if you know Scala, then also you can get placements in Spark with Scala also. So if you know Scala, you can get chance to work on Spark with Python also. So there won't be any issue. If you know only one of them also, that will be fine. And in Spark, we'll explain about basics and code. Again, it is divided into four parts: core, SQL, streaming, graphics, ML. Graphics ML generally it won't come under big data. So we'll cover Spark core, Spark SQL, and Spark streaming. Those parts will cover. And maximum work you will get in Spark only if you get any project. And coming in Spark, we can have like, what are the data we are getting from different sources in any project. We have two different process. One is like live, another is batch. Live is like whenever you get any data from source systems, we need to update them. So if within few seconds we need to update, so those type of work we'll call it as live projects or live streaming. And another is like batch. So we'll have certain time interval. So after that particular interval, we need to execute for example, before 9 o'clock every day, this data has to be updated. So for those type of work, we'll call it as batch jobs. So in Spark, there will be two. One is batch, another is streaming. We'll explain both of them. Coming to the streaming side, there will be two. These both will come under streaming set. So this is for messaging queue, Kafka. We'll explain little bit about Kafka and how we need to use. And in streaming, we generally prefer to use Magnum projects with Spark only. We'll explain how you need to use streaming with Spark. And storage side, we will explain. One is Hive. So this is default database for maximum projects, and based on their requirement, what type of projects they are getting, how they need to store the data. Based on that, they may need to use different databases. One is like NoSQL DB. We'll explain a few of NoSQL DBs. You will get idea, and maximum NoSQL DBs will be in similar format. So basically, we'll cover all these. So first, we'll cover all these topics in on-premise. You will get better picture when we will explain in on-premise. After that, in cloud, these features how we need to use in cloud. For example, if you take AWS, so if you take AWS, all these features how we need to use in AWS or Azure, we'll explain later on. So after that, we'll provide one live projects, and we'll ask you guys to do some small tasks. And yeah, this is live project. So this is the overall curriculum. If you guys have any doubts, please let me know.
Hello, sir. I'm Shalika.
Yeah, can you speak little bit loud?
Hello, sir. I'm Shalika. Can you hear me?
Uh, Unable to hear you. There is so much background noise.
How about now, sir? Can you hear me?
Kavita, you can keep your doubt on the chat window. We'll check and answer that. Jagdish, what about the duration? How much time it will take to complete this?
It will take around these basics itself. Three, it will take around more than 1 month or around 1 month. So overall, it will take, including live project, 2.5 months around,
Three, two and
from
a half to
two and
three,
a half
roughly, we
months
can.
to 3 months. Yeah.
Mm, okay. It is. Okay.
So Jagdish, one more thing. Some people asked me, if they are just freshers, how they can cope up with this course? If they do, they need
Uh,
any? Yeah,
for
can you
fresh,
please?
for sake of freshers only, we added these three topics. Uh, Python basics, SQL basics, Unix basics. So this is mainly for freshers. If they have already experience with if they know all these three topics, then directly, uh, generally we'll start from introduction to Hadoop. Because of freshers, we added these three topics. It will take extra 1 month to cover these three topics only.
Okay, I think Shravika typed her question in the chat window. Sir, my doubt is, in general, people who tend to opt for data engineering role, they start with software engineer or business analyst. But as a fresher, how challenging it would be to go to directly to data engineer?
Uh, Generally, those who are working as software engineer, for them, different projects will be there in company. Directly, if you have these big data profile, right, there are huge openings, so it won't be much difficult to get directly into big data projects. But if you have already basics, they will prefer those candidates, those who have at least basics.
And Shavika, few years back, like almost 5 years back, there's a process of knowing the software technologies and what need to be done and all those things. But now even freshers are getting job into data science and data engineering. As in BTech curriculum itself, they included machine learning, data engineering, data science, and all this in their curriculum. So even freshers can handle this if they know the basics and proper structure of learning.
I hope that that
Okay.
answered your question.
Yes, she replied on the chat window. And we'll be providing an internship certificate for the project, so that mostly for freshers, whoever are taking these sessions and all those, for freshers, it would be difficult to get a job opportunity without any hands-on experience. So it would be helpful for freshers to get an internship certificate.
Will be providing the internship certificate and hands-on experience, and
Mm,
there will be working on the live project
mm,
with optimum level of usage, how the companies, what are the
mm.
technology or methodology used in the companies, right? The same thing will be applicable here also, so you will get the
So,
direct exposure towards that. More question I received on my mobile related to this data engineering course. The question is that if they are changing from one domain to other domain, right? Like currently somebody is a Java developer, or one person is into testing. So how they can come to here, and how they can manage the things in the data engineer?
Like if they start learning Python, one programming language, Python or Scala, and little bit basics on SQL side, then it will be easy for them. So if they know basics of these two, programming language and SQL, then it is easy for them. No, they won't feel any difficulties. Start working, it will be almost similar. And for example, if you change different industries, domains also, for example, retail domain to telecom domain, so from big data engineer side, there won't be much difference. So whatever the s- uh, process we are using in retail domain, it will be same in uh, telecom domain or banking and finance side. So in that side, there won't be any issues for them. It will be almost same.